Welcome to Hardware Asylum. We're back working on the Retro PC subwoofer project. If you're unaware, this project was designed to be a standalone subwoofer for my Retro PC projects, but it could easily be adapted to any modern PC or home theater. My intention was to build a compact subwoofer built around the Tangband 5¼ inch drivers that could not only be powerful, but also hit some extremely low frequencies, which of course is something that retail computer speakers could not do. In previous videos, we experimented with different box designs, from a clamshell isobaric enclosure to various compound ported boxes, until I finally settled on a dual driver bass reflex design. The prototype turned out extremely well, and so I rebuilt it with some custom wood veneer, 3D printed accessories, and a nice black finish that it honestly kind of fought me the entire way. While the box has been completely assembled and tested and used for quite a while, I never did a follow-up on what the sound quality was, and that will be the focus of this video. Like before, we will be using my Focusrite Scarlett 8i6 audio interface. This is the same unit that we used to record the Hardware Asylum podcast. It's extremely versatile, and I've been using it for streaming on Twitch as well. I am using the line level outputs from the Focusrite to supply signals to both the subwoofer and my set of Creative T40 desktop speakers. The Creative speakers are a full range design but lack any substantial low-end frequency response. On the subwoofer side, we're using the Dayton Audio KAB100M V2 100 watt Class D amplifier. What a mouthful. Comes with a built-in DSP that can be used to set crossover frequencies and make minor adjustments. Personally, I prefer that my subwoofer enclosures be passively tuned, which means that I don't have to change the input frequency with equalization or DSP, but I like the idea of being able to tweak things at the amplifier level. Like before, the Creative T40 and the subwoofer were leveled using a target amplitude of 80 decibels. We'll be using this as a point in REW, or Room Equalization Wizard, to evaluate the various frequency curves. I started out with a basic test of the subwoofer. The green line is the frequency, or RTA, while the orange line is the port tuning. The highest point on the orange line is the port tuning frequency. I was targeting 32 Hertz, and it's exactly what I got. Now, if we overlay the results from the prototype box, we can see just how close we are. For port tuning, the final box is a couple Hertz off, hitting lower than expected. Now, the port length is exactly the same between this box and the prototype box. However, the volume of the box did get slightly larger, and that change, how minute it is what really dropped the frequency here. As we switch over to the frequency response charts, we can see something really interesting. On the surface, things look similar. However, we have a bump at 30 Hertz, which was not there in the prototype box, and a major dip around 60 Hertz. Of course, the larger box volume wouldn't contribute to this, so what gives? Between the two designs, there are 4 major differences. First was the overall construction. The front and bottom on the final box were 3/4 inch MDF to accommodate some of the design features I wanted to add. On the original box, there were still 1/2 inch MDF. I had already mentioned that box volume was a non-issue, but it's still on the table. Next was the amplifier change. The prototype was using a lower powered plate amplifier that was really designed with a built-in crossover and intended to be used in a 2.1 channel system. The built-in crossover on that amplifier works at both the low and the high end at the same time, which can lead to holes in the real-time analysis curves. The final change was actually an accident where I had placed the 2 speakers extremely close together. You can see that in other pictures where I printed those orange rings that went around the subwoofers. That's a little bit of a decoration, but the speakers themselves were touching at that point. I suspect some of the changes on this curve are 100% the amplifier. For instance, the lower frequencies are amplified a little bit more than they really should be, and then there's a hole at 60 Hertz. A good amplifier wouldn't have holes like this, but we have a Dayton Audio amp, and it's not really that expensive to begin with. Now, that bump at 30 Hertz, that had me scratching my head for a little while. My conclusion is we have a phase interference between the 2 subwoofers. Unlike on the prototype, these are wired in parallel to drop the ohm load down to 2 ohms. And as the subwoofers move, they're flexing on each other, and one of them just happens to be slightly out of phase. And by doing that, it's causing the other one to act as a passive radiator and boost that frequency just at that one point. Now, despite this, the box sounds amazing, super powerful, but I wanted to fix the curve, and that is where the DSP comes into play. Now here's what I ended up with. I moved the crossover point out to 120 Hertz and set it to a 24 dB slope, or that's really what it should be. You do this by adding a second low pass filter at that same frequency. Ironically enough, they don't need to be near each other in the software. Next, I started messing around with the frequency compensation. As you can imagine, these curves are not all that accurate, and by changing one frequency, you're actually changed the entire curve. For instance, by boosting 35 Hertz, in an attempt to knock down that 30 Hertz bump, it fixed the issue at the droop at 60 Hertz. There was also another hole I wanted to fill around the crossover frequency, and to fix this, I needed to tweak both 90 Hertz and 120 Hertz, but of course not by much. In the end, I was getting a very nice frequency response that got rid of the dips, flattened the curves, and provided a noticeable change in sound quality. I will admit I'm not a fan of the Dayton Audio DSP or the software, but it does help if you're tuning a system for a certain sound profile. Personally, I liked how the untuned box sounded. The bass was very rich, though matched up with the T40 speakers, you could tell there was something missing in the mid-bass range, namely right at the crossover point. These DSP adjustments filled the gaps and made the whole system sound really good. Of course, that doesn't take into consideration room dynamics or speaker placement, but all of that will change once we swap out the creative GigaWorks T40 speakers with just about anything else. Overall, this project was a ton of fun, but we're not done. In the future videos, I plan to design a set of desktop speakers and a center channel specifically for this subwoofer, and we might mess around with some dual driver bandpass designs. Until then, I wanted to say thanks for watching, thanks for subscribing. If you have any questions or comments, please leave them down below, and I'll see you in the next one.
Eurotech sound. Eurotech sound.